Hi, so today we will going to move to our another topic. So basically starting from this topic, we will going to move into a layer 2, okay, or we call it as a data link layer. Okay, so basically on the previous lectures, okay, we're going to learn about what actually is the IP addressing, IP routing, and then you're doing the dynamic routing protocol of the OSPF. Basically, we are focused is under the layer 3 network layer. Okay, but starting on this week, we will go into move now again into a layer 2. We call it as a data link layer, or most of the times you are going to look in on this terminology. We call it as a Ethernet switching. Okay, so basically on this topic, we were going to learn about what we means by the Ethernet. Okay, what actually is a Ethernet switching, and then how you going to enable the communications. Okay, under the data link, basically you were going to deal with the Ethernet switch. Okay, so remember switch, we have a layer 3 and also we have a layer 2 switch. Okay, so Ethernet switch most of the times we say is a layer 2. Layer 3 most of the time is your core switch, is your aggregated switch there. Okay, so we were going to learn about the Ethernet protocol. Okay, and also the layer 2 VLAN. We call it, I recall back, on layer 3, we call it as a package. You going to using is your IP package, right? So on your level 4, okay, you have your TCP and also the UDP segments there. Okay, but when you move to the layer 2, we are going to talking about is your Ethernet VLANs. Okay, and also we were going to deal with the MAC address. Okay, or most of the time, like your week 1, we're going to see how actually you going to IP configure R to get your physical address as your MAC address there. And then we were going to understand all the working procedure. And of the layer 2, basically we were going to learn about the protocol, what we means by the VLAN, and what actually we means by the STP. But on today's, basically we still go for the fundamentals. You are going to understand the concept of the Ethernet. Okay, and then you are going to learn the, we call it as a friend, okay, of your MAC address. And then how actually the working process of the layer 2 lah, how actually whenever I receive a friend, okay, what actually the switch we're going to do, just like your layer 3 router, but they have a different kind of the package. We call it as a friends forwarding and also the discussing there. Okay, so and also you were going to learn about under the layer 3. Okay, you have a routing tables, right? Routers, you have a routing table in order to forward your package into your next hop and go through your destination. The same things under the layer 2 Ethernet switch, we have a switch, and then under the switch we have a MAC address tables. We are going to learn how actually we going to generate the MAC address tables. Okay, so under the Ethernet protocol, basically most of the times we're going to mention is under your local area network LAN. Okay, under your local area network, or most of the times we're going to call them is just a Ethernet. Okay, so remember the Ethernet network, okay, is a broadcasting. That means whenever I going to receive a package, okay, from the host A, so I will try to broadcast to host B, host C, and host D. So that's why we said the Ethernet is a broadcast network that built based on the CSMA correlations detection, CSMA CD mechanism. So this one basically on which one we're going to learn the fundamentals of the all the devices. Basically, you already looking on this go through the explore of this what we call it as a CMMA CD, carrier sense multiple access and collisions detect. Okay, we're going to refresh again what we means by collisions domain. Collisions domain is whenever you have a set of a host under the broadcast domain. Okay, so basically, how to say, on the share network, so the Ethernet we're going to using the CSMA or the CD technology to avoid the collisions. Okay, basically, most of the time, a terminal, they will continue to detect whether the share line is still inner or they have any data sent or not. So for example, of this example, if let's say the host A, I want to send out my data. If I going to enable the CSMACD, that means the host A will going to distance into the network, whether the host B, host C, and host D, they got sending out the data or not. Okay, if they are got sending the data under the same network, so I will not going to send my VLAN first. I will wait things. But after that, if let's say host A going to send out the data, host B also send out the data, host D also going to send out the data, we say the collisions will be happen on here. So we also under the week 1, we're going to learn how actually we're going to split the collisions. Okay, domains. We need to apply a switch or we need to apply a bridge to break the collisions domain. Right? You learn how you're going to calculate how many collisions are domain on here. So this one is on the week 1, you have learned it. So remember, we recall again under the layer 2, okay, because it's a broadcast domain. Okay, so on the switch they apply is a CSMACD. So how you going to break the collisions domain? You have to apply a switch or the bridge going to break it. Or another choices you can apply is a VLAN technology days lah. Okay, so another one collisions domain VLAN you can going to break it. But VLAN most of the times we're going to break it as a broadcast domain. Okay, the same thing on here. Whenever we're going to receive the package, remember just now I mentioned layer 2 Ethernet is a broadcast. Okay, when you're going to receive the package, you don't know where is it the destination. It's not like a layer 3 you're going to discuss. If let's say on the IP router, okay, if the package, I cannot going to find out the destinations, okay, matching. So what happened on the layer 3 routers or layer 3 devices, you were going to discuss the package. But under the layer 2 data link, layer 2, you're not going to discuss the package. Okay, you were going to broadcast to the package to all the hosts. Okay, so to check whether they will be received or not lah. Okay, so remember you were going to broadcast. So how actually I know that one is a broadcast? Normally we were going to base on the MAC address. Okay, that means you were going to set your destination is a FFF. Okay, later we were going to learn on it. Under the Ethernet, we have a unicast, we have a broadcast, and also we have a multicast package and how we're going to differentiate it. But before that, we're trying to deflash again on the week 1. What's actually the theoretical we have went through under the correlations and also the broadcast domain on here. And also you going to looking on here under your broadcast domain, you also be explore, you were going to apply the router or any layer 3 switches to break the broadcast domain, or you can apply the VLAN to break the broadcast domain. So VLAN we will going to cover on the next following topics on that one. Okay, so this one we just going to deflash again. So normally, sometimes they will give you a questions. You need to know how to calculate the correlations domain. So correlations domain, remember just looking on your switch. Okay, so hub did not going to break your collisions domain. So based on your switch, so here you got how many switch? So 1, 2, 3, 4. But at the same time, you also have a router. Router also able to break the collisions domain. Same like your VLAN. Okay, and then if you want to break the broadcast domain, you have to base on the router. How many interface they have? 1, 2, 3. So you have break into a 3 broadcast domain. So this one basically we have went through on the week 1. Okay, so remember, sometimes they were using a different terminology. Repeaters is equivalent to your hubs, and then bridge is equivalent to your switch there. Okay, so that means the repeater and hub, they cannot going to break your collisions and also the broadcast domain. But the bridge and also the switch, they are able to break the collisions domain, but not the broadcast. Broadcast, you have to using a router or a VLAN or a layer 3 switches. But most of the time, the switch here we are refer is a layer 2. Okay, so now we move to the first concept that you need to learn under the layer 2 Ethernet or the data link layer. Okay, is a NIC. So NIC stands for a network interface card. So all the devices that you are able to connect, okay, to the network. Okay, basically you have equipped the network interface card, which they have been produced by the manufacturer. Example, Huawei have the Huawei one, and then the HP have the HP one. Okay, we have a different vendors, so they have their where how actually you going to determine your NIC and also to determine your MAC address there. Okay, if you cannot remain imagine, okay, you just need to know there are many types of the NIC. So on here, because we're going to explore is a Ethernet. So most of the time NIC here we are going to refer is your Ethernet NIC lah. Okay. So this one is the example. Okay, you have your network card. Okay, you install, so you have your port, network port. Okay, it's also called the network interface lah. Like normally you going to pasang your routers and then you're going to link under your G00. So this one is your network port there. Okay, so remember each of the network port basically they are equivalents to the NIC. Okay, so now we were going to learn in details the VLAN. Okay, we recall back under the layer 4. Okay, the transport layer. You have learned what actually is a segments of the TCP and also the UDP headers. Okay, so recall back TCP you only have a 20 bytes and then UDP you have a byte. Because this one normally for the students when they move to the different layer, they confuse all together. Okay, so that's why it's better for me to deflash you before we going to learn another layer packet headers there. Okay, so this one is under the TCP and UDP. UDP, you only have a byte, source port, destination port. Okay, but on the TCP, you have more informations for here for you to do a three-way handshaking whenever you're trying to open the connections and closing the connections with a four-way handshaking there. Okay, then you also move to the layer 3. Okay, on the network layer, you learn about what actually is a IP packet. Okay, your PDU is a package. So remember, package, your fixed header size, you have a 20 bytes. Okay, just like your TCP, but you can up to the maximum 60 byte is depending whether your options here. What actually the size is your optional. Okay, then now we will move to the layer 2. Okay, so recall back the layer 2, the PDU, okay, protocol data unit, we call it as a VLAN. Okay, under the layer 2 Ethernet, we have two types of the friends, two types of the technology and also the standard of the friend. We call it as a Ethernet 2 and also another one we call it as a IEEE 802.3. Okay, so basically what they are different is depends on the Ethernet IEEE 802, they have the additional informations on here. Okay, so which one it will be widely using under the industry? Most of the times we're going to Ethernet 2 compared to the IEEE 802.3 formattings there lah, because they have the additional. I mentioned it's a Ethernet. Okay, so now you're looking on here. What actually we means by each of the field and how many bytes on here. So here 6 bytes, that means 6 times 8. 1 byte you have a bit. So basically you have a 48 bit for your MAC address, destinations MAC address and also the source MAC address. Okay, the types basically on here, you were going to determine the types of the services, okay, that you are going to offer, the protocol types. Okay, so most of the times later we were going to see, most of the times we were going to holding the IPv4 or the ARP. Okay, we were going to see the number is 800 and 800.04. This one always they were going to ask it, but on the next slide. Okay, but on here you can going to see your user data on here. You were going to consume starting from the byte 64 until 1500 bytes there. Okay, so another you have a frequent checksum on here lah. Okay, is for you to do some of the checking. Okay, but under the IEEE X02 frames, they have the additional, we call it as a LLC, the logical link control layer. Okay, so this one is basically they have a DSP, okay, destinations service access point. Okay, they also have a SNMP, okay, or of course normally they will have a package there. Okay, they call it as a destination DSAP. Later, another slide you were going to see lah. Okay, and then you have a source service access point. Okay, and then you have your SNMP also lah. Okay, this one is under the Ethernet. SNMP is stand for the subnet access protocol. Okay, so just remember the total frames, okay, for the your data. Okay, it will going to starting from the 64 bytes to 15118. Okay, so the maximum it will be up to a 1500 there. Okay, so what actually is a minimum? If you're going to calculate on here, what actually is a minimum bytes for your Ethernet network? So minimum it will be consumed is a 64 byte for your frames. Okay. So the next one you are going to look in detail example on the Ethernet 2 frames. Okay, what you need to remember on this slide, always they were going to asking you the protocol on here. Okay, but these two, it will be the famous asking. So remember, if the number has a decimal here at 100, it stands for the IP protocol. But if the X06, it stands for the ARP. Okay, but if you got more memory, then you can go into memorize more. Okay, X035, okay, the reverse ARP. And then you have the VLANs at 100. Because VLAN later when we're going to move, learn for it, you also will going to explore on it. Okay, SNAP is at 14C. Okay, so this one is all the protocol. Okay, that will be under the Ethernet. So when you're going to carry the flames, you are going to know what actually is a protocol. Just like your IP package, right? You have an IP and also you have the IPX, and at the same time you are going to telling what actually is your upper layer TCP or they are the UDP there. Okay. So this is one of the example questions lah, how actually they going to come out. Okay, so remember for the protocol here, you are actually differ into a Ethernet flame, but your formatting on the Ethernet, it should be the Ethernet 2. Okay, and then if the 800 is stand for the IP package lah. So answer it should be A and C there. Okay, now we're going to learn into another flame. Okay, we call it as a IEEE X02.3. Okay, so this one actually some of the older we cannot say is deprecated, but how to say it's not commonly applied in the today's networks lah because of their heavy additional and complexity there. Okay, so actually it will going to result the overhead when they going to your Ethernet, your switch, going to process your package. That's why IEEE X02.8 FLAN, they are not commonly applied in today's network. But remember, we still have some legacy or the older protocol. They actually are using the Ethernet lah at 02.4. So for this one example, for those example, if you are using the STP, so you will still will going to have your SNMP here. Okay, you will going to using your protocol number. It will be a 0x03 lah. Okay, so this one it will be under the IEEE X02.3. But compared to most of the times in the today's network, we're using a Ethernet 2 flag for the Ethernet network lah, data link. Okay, so the second concept you need to know. Now you already understand what actually is a PDU, okay, protocol data units that you carry under the layer 2 is a FLAN, Ethernet 2 FLAN or IEEE 802.3 FLAN there. Okay, the next second concept that you need to understand is your MAC address. It's just like the same thing under your layer 3. Okay, you go into forwards your package, you have the IP address. The same thing under the layer 2 data link layer. Okay, we have the address, we call it as a MAC address. Okay, so this MAC address is a little bit different from your IP address. Later, we were going to see one slide to differentiate it. But you need to remember your MAC address is unique identifiers based on your NRC. That means each of the NRC, they must have a global unique MAC address there that consists of a 48 bits. So that when your PC, you're going to connect to the internet, they actually know who actually are connected. Okay, so we're going to see the differentiate between the IP address and MAC address. Of course, IP address, you are going to do it under your layer 3. Okay, and then MAC address, you are going to do it is under the layer 2. And IP address is changeable. That means you can go into based on your private network, okay, or your private network, and then you're going to assign, and then you're going to form your IP address. It's changeable. But remember, MAC address, you cannot go into change it because it's determined by your manufacturer, your vendor. Example, Huawei, they have their own types. Okay, so remember, MAC address, you cannot go into change it. Okay, the next one, you are going to look in on your MAC address. How actually we going to read the MAC address? MAC address is different from the IP address. IP address, all you're going to represent under the decimal, right? Decimal points, and then it's a 32 bits, right? So you have a 8 bit, 8 bit, example, you change it into the decimal, okay, 192.16 at 1.1. So you have another 8 bit, 8 bit, and 8 bit. For X, you consume to a 32 bits. So this one is your IP address, layer 3. But when you move to the MAC address, we are using a hexadecimal, okay, and then we have a 48 bit, that means a 6 byte. So most of the times they will do a pairing, that means they will going to assign two. Okay, 1 equal to 4 bit, 1 equal to 4 bit. So here actually you have a bit, 1 byte. Okay, 2 byte, 3, 4, 5, 6. So here you have a 6 byte. Total you have a 48 bit. So again, we will convert into a binary. Okay, because when you're going to learn the different type of the FLANs, then you are going to know how actually you're going to differentiate. That one is a unicast, multicast, broadcast. Okay, but remember the broadcast just now on the beginning of the class I already mentioned is all it will be your MAC address. It all will be the FFF. Okay, but this one, if you're going to look in, it will be your unicast, your unique MAC address there. Okay, remember MAC address, you have a 48. So how you're going to convert is just like normally how you're going to convert into the binary Okay. So the next one, the MAC address. Why we say the MAC address is a unit? Because when you're going to look in the compositions of the MAC address, OUI is stand for the organization's unique identifier. For example, the Huawei one, they have their unique. I forgot the number already. Okay, I need to, you can go into check back if for the Huawei. Last time I remember, but now I forgot already. So you can go into check back what actually is their MAC address. Okay, let me go back to that one. Okay, so normally OUI, okay, for the first 3 bytes, okay, is a 24 bit, it stand for the OUI. The rest is actually stand for your CID. So this OUI is a organization unit identifier, and then it's a global unit identifiers assigned by the IEEE there. Okay, just now I mentioned when we have a MAC address, we actually can go into differentiate, okay, the broadcast address. Okay, that means all is 111. When you convert into the hexadecimal, they will give you a FFF there. Okay, berapa? You have a 6 pasang. 1, 2, 3, 4, 5, 6. Okay, 6 times 2, 12 lah. 12 characters there. Okay, but if let's say it's a unicast, how I going to differentiate? For the broadcast is very straightforward. You just look in FFF and all your binary is a 1 that I know is a broadcast. But on the unicast, we will going to look in on the 8 bit. Okay, it's a 0. Binary, binary is a 0. That means it stands for a unicast. Okay, if for the multicast, the 8 bit, okay, it should be true, 1. Okay, so that means it will be a 0, 1, 0, 3, 0, 5, 0, 7. Okay, why? Okay, example, if let's say I have a 0, 0, it will change it to be a 0, right? 0, 1, it changes it to be a 1. 0, 2, it changes it bukan 0, 2. 1, 0, it will have a 2. 1, 1 is equal to 3. 1, 0, 0 is equal to 4. Okay, so when you're going to look in on this kan, you look in example here, you have a 6 bit lah. I did not going to write all together. Okay, you have another 0, 0, 0 on here. So you look in on the 8 bits, the big ke-8. Okay, if they are the 0, 0, so that means they are the unicast 0. Okay, 2 also is a 0. 4 also is a 0. So 0 to 4 is a unicast. Multicast is a 1, 3, 5 because 0, 1, okay, 1, 1, okay, and 5 you can 1, 0, 1 on here. One more example. So big ke-8. Okay, so it will be as your multicast. So this is the way how we going to differentiate lah for the what actually the MAC address is stand for the unicast ke multicast ke broadcast. Okay, so you looking on here. Okay, what we means by a unicast. Okay, unicast is very straightforward. You just need to look in on the number big ke-8. It should be kosong. It should be a big 0, false. Okay, then always whenever your destination is a unicast, that means you were going to send to specify to the example. If let's say the MAC address of the host B is this one. Okay, so basically you were going to forward your package to a host B. You are not going to forward to the PC1 or PC-D. This one we means by the unicast. You only send to particular one host only. But if let's say we say it's a broadcast, okay, or is a 1 and or is a FFF. So that means you were going to send to all the hosts under the same Ethernet switch network. Okay, so if let's say it's the multicast, that means we base on their subscriptions. Okay, if example on this example, I group the host A, B, C, A, B, D is a one group. Okay, so when I going to detect the big ke-8 is a 1, is a true. So I know this address is a multicast. So I will only forward the plans into the particular host that belong to a same group. So that one we call it as a multicast. Okay, example of the questions. Okay, how you going to determine which of the address is a multicast? So now they give you is a hexadecimal. So it's very straightforward kan. Just now I already mentioned to you. If looking of the multicast, you need to look in on the big ke-8. Okay, big ke-8 it should be a 1. Okay, that means you look in on here big ke-8. You convert lah, mana satu ada on here. 2 is definitely no. Okay, the small tips basically just now if you're going to look in on my explanations, you already understand on it. Okay, if let's say I put the 0, 8 big 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 1. Okay, so this one is a binary. You convert into the hexadecimal is equal to 1. So here 0, 0, 0, 0, 0, 0, 1, 0 is equal to 2 on your hexadecimal. So 0, 0, 0, 0, 0, 0, 1, 1. So this one is equal to your 3. 2, 2, 2, 2. Okay, so you go to the 4. 0, 0, 0, 0, 1, 0, 0. So this one is equal to 4. So you continue 0, 0, 0, 1, 0, 1. So this one is equal to 5. So 0, 0, 0, 0, 0, 1, 1, 0. So it's equal to a 6. So 1, 1, 1 is equal to a 7. You just fill in 0, 0, 5. Okay, is equal to 5. And then you have a 1, 0, 0, 0 is equal to 8. So here you have a 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and then 9. You have a 1, 0, 0, 1. Okay, hexadecimal. So that means you were going to change to be a 1, 0. So you have a A. So you fill in depan ada 4 lagi. Okay, and then you have your B is a 1, 0, 1, 1. Okay, then you have your C is a 1. Why cannot? 1, 1, 0, 0. Then you have your D 1, 1, 0, 1. Okay, you have your E. I tak cukup do this. 1, 1, 1, 0. And you have your F is a 1, 1, 1, 1, 1. Okay, just now we mentioned if a multicast you looking on the first 8 bit. So bit ke-8. Ini bit ke-8 is a multicast. 1. Bit ke-8 ialah 1. Okay, and then you looking on here also 3, yes. Okay, 5, yes. 7, also yes. 9, also yes. B, also yes. So you already find out the patterns kan? As long as there is a odd number. So actually it will be a multicast. As long as they will be the 2, 4, 5, 6. Ayo. Where is it? 2, 4, 5, 6. 2, 4, 6. Okay, even number. So that means they will going to have is your unicast. Is your unicast. Ayah, battery low. So that one, it will be your unicast. Here, it will be your unicast. So as long as the number kedua is a even number, so they will be a unicast. So now they give you the question is to find out the unicast. You just look in the second number. Which one is a odd number? So A bukan kan? Okay. B, yes. Right? You starting A, B kan? B is a 1. So this one is C, no. 2, also no. So your answer is B. So you no need to calculate one by one now because you only 60 question 1.5 hour. Basically, you just one questions you have 1 minutes, 5 minutes, 1.5 minutes. So if you're going to calculate like this one, you are wasting the times. So you just keep in mind, you just looking on the second number. Okay, select whether they are the odd or even. So if the odd number is a multicast, even number is a unicast. That's all. So now you're looking for the unicast. So you're going to look in on here. Okay, B. Okay, now we're going to move. Okay, now you already understand the basic concept of what we mean by the Ethernet friends. Next one, we will going to move to the switch. Okay, where we going to apply the layer 2. Okay, on the last previous week, we're going to look in on your layer 3. Okay, basically you can going to make your core switch. Okay, and also your aggregation switch is a layer 3 devices, or you using a router lah. Okay, but within the same campus, you can going to make that one is a layer 3. So where is it your layer 2? It will be under your access layer. So on here, we call them is a layer 2 switches on here, which they will going to connect to all the hosts. Okay, all your departments, computers there. Okay, so that one is where you're going to apply whatever concept you are learned under these few topics lah. Switch. VLAN STP. Or in the VLAN is you apply some mixing with the internet layer 3. Okay, so you're looking on here how actually the working principle of the switch. Okay, the first thing is you need to know how the switch they're going to learn the MAC address table. They will going to learn based on the source. Okay, this one is very famous questions. They always will going to asking under the HCIA Datacom examinations. How the MAC address they're going to learn, okay, to generate their MAC address table. So remember, they based on the source, not based on the destination, based on the source. So on here, the first thing when the switch, they go in, example, I just going to plug on. Okay, I don't have any tables under my MAC address tables. Okay, normally my MAC address table, I will going to keep the MAC address tables, MAC address, and also my interface on here. Okay, so when I just fully plug in, I don't have any entry on here. So how I going to generate the MAC address table? I will base on the package or the frames that I receive. So for example, now the host A, they're going to send to me the frames. Okay, they were going to determine, okay, the source of the MAC address is a 005056000001. So I received from the G001. So what happened? I will going to learn it. Okay, this MAC address 005056000001. I learn, okay, is from the G001 interface. Okay, the same things when the host 2, they sends the package to a switch. Okay, they also based on your source MAC address. So they were going to record lah. So this one is under the same one, but it's 002. So I'm going to learn it under the G interface 002. Okay, this is how the MAC address table will be generated. Okay, when I going to receive the package at the frames, so normally I will going to check my MAC address tables. Okay, if the entry, this one is different from the routing tables. If the entry is exit, you are going to forwards. Okay, if the entry is not exit, okay, that means you cannot find the MAC address matching one, cannot exit. So you will going to broadcast flooding. Difference from the IP routing layer 3. Layer 3, you will base on the how you going to do on it. First thing, remember you will base on the longest match. Okay, if longer match, you are going to base on the protocol preference number. Okay, then after that, you are going to check in on the cost. This one is how the IP package. But if, let's say, on the IP routing tables, I cannot find out the destinations when I'm going to receive. Under your layer 2 switch, you are going to flooding to all the hosts. Okay, but under the layer 3, that day I mentioned scan, you were going to do is a discuss. Whenever it's not exit, you were going to discuss. You buangkan the package. But remember, when you move to layer 2, you will do is a flooding. Don't confuse. Okay, so how actually the process behavior of the switch? Okay, they will do a flooding, they will do a forwarding, also they will do a disgusting. But disgusting is a special case. It's not like the layer 3 routing, not exit, you're going to discuss. It's later we will going to explain one by one. Okay, now we're going to look in on the first scenario. Whenever I receive the IP package, how actually I do a flooding. Okay, so when I going to receive the MAC address 1, okay, so I going to learn, okay, so I receive this because when I going to send the package, right? So my friend, my source MAC address, it will be MAC address 1. By destinations where I want to send, it will be a MAC address 2. Example, I want to send to host 2. So MAC address 2 is my destination. So what happened when the switch they going to receive it? So they were going to learn. If let's say they are the empty, they were going to learn, okay, MAC address, I learned from the source scan. So I going to record it. MAC address 1, okay, 001. So I received actually from the G001. But now I want to send on the MAC address too. Where is it I need to forward out? So I did not exit. So what happened? If not exits, they were going to do is a flooding broadcast. So they were going to send all the devices that connected to this switch except the interface that they received lah from host 1. They were not going to broadcast lah. But the rest they were going to flooding broadcast on it. Okay, this one is the first scenario. Whenever you receive, but you don't have the entry, okay, for the destinations where you want to send out your package. FLAM there. Okay, but second condition is your destination is a FFF. This one is whenever recall back on the week 2, we learn about the ARP. Okay, you're going to send the ARP request because you move from the IP package. You have the IP address of the host 2, but you don't have the host MAC address. So how actually you're going to do? You need to send out the ARP request broadcast. Okay, destination is a broadcast. So this is another scenario where the switch will going to flooding your flames, Ethernet flame. Okay, so and second scenario is when is it they were going to forward. As long as, example, if let's say now the MAC address 2 is exit under my tables, I can find out can. Okay, I want to send to the MAC address 2, I have to go through a G002 on here. So I just going to send the flames to the host 2. So in that scenario, we say we just forward your switch, just forward your data because it's exits under your MAC address entry there. Okay. Okay, we're going to look in on what scenario that actually we're going to do the discussing. Okay, discarding. Okay, under the layer 2, we actually will do the discarding, but it's not like the layer 3, okay, of the routing tables. If you cannot going to find out your routing table, so the IP address destinations under your routing table, so your IP layer 3 you were going to discuss. But under the layer 2, is a different story. Okay, if you cannot going to find out the entry, you will going to broadcast. But in what scenario, what conditions, your switch will going to discarding your flame. Okay, so it's basically you have to look in on here. Okay, just remember if the interface number in the table is the number of the interface to which the flames enter the switch over the transmissions medium. In this case, the switch we are going to discuss the unicast. What is mean on here? Okay, we looking on this example. Okay, example for your frame what host 1. Okay, you have a source MAC address and you want to send to the MAC address 2. Okay, when the switch 1 they going to receive on it because they don't have the entry under their routing MAC address table. So what happened? They were going to do a broadcast. Okay, but on the switch 2, when they going to receive, okay, so what happened? They were going to check on the MAC address tables that generate by the switch 2. So they were looking, how come this one your destinations, okay, address is a G001, right? Destination it should be Z001. That means supposedly I going to forward out, okay, it's the package will the 001. But now I actually going to receive the package. So in that scenario, we means on here, okay, is the number of the interface through the flames enter the switch. Supposedly we need to forward out, but they going to receive on it, right? So this is the conditions lah, where they will, in that case, they will know, oh, actually this one is not intended to me already. So I will going to discuss it. Okay, because it's supposedly going to forward out, okay, and then going to forward to the host 2 lah. Okay, so this is the scenario where we were going to discuss your Ethernet flame. Okay, the next one is how actually we're going to learn the MAC address law. Just like what I said, we learn based on the source of the IP address. Okay, we base on the source of the IP address. So for example, on this one, okay, we have a source and then we want to intend send to the host 2 for your destination. So what happened under your MAC address table whenever the switch is receiving? So they were going to record the G001. Actually, the source is the MAC address one. Okay, source. So if let's say they cannot go into find out now your MAC address too, they cannot go into find out under their entry. So what happened? They were going to do a flooding to all the interface there. So remember the default aging time. This one also have been asking under the HCIA is 300 seconds. Okay, how actually they going to keep the MAC address under the MAC address table. So they have a default aging time is 300 seconds lah. Okay, to update the entry that you have learned under the switch. Okay, so after that, when they going to received by a host 2, now host 2 say, hey, I am the holding this MAC address. So example, you can go into send the ARP deploy flames, okay, to the host 1. So the same thing on the switch 1, because now you're going to send out your source address is a MAC address. So they're going to record, okay, this one is sent from the MAC address to, actually I going to receive from the G002. So I going to generate and learn the MAC address lah. But remember, by default, if you did not going to change it, all the entry here by default they were going to keep is a 300 seconds only. Okay, now we will going to look in on how the scenario for the process of the data communications within the network segments on here lah. So basically, this one is whenever you going to receive, okay, host 1 you want to access the host B. Okay, now you're looking on the IP address. Okay, the host, most of the times you only know the sendiri punya IP address. Okay, and also the MAC address. But now how actually you going to reach out your host 2? So basically, you need to go through, is example lah, the first time I don't have any entry or whatever. So recall back on the week 1, we learned about the ARP to match your IP address to the MAC address. We were going to flooding kan. Hey, which of the host actually holding this IP address? Broadcast kan. Then they were going to deploy, hey, I'm the one that holding this IP address with this MAC address. So they were going to generate your ARP entry and then they were going to update your MAC address lah. Okay. But on here, what you need to try to understand, we recall back on the data encapsulations. Okay, when you going to move, going down to your layer, upper layer to lower layer, so you will do the encapsulations. So now you move to the data link layer. So you will go into encapsulations, the extra Ethernet headers and also the Ethernet tail there lah. Okay, this one is under your IP headers is under layer 3. TCP header is under layer 4. Okay, but we call it as a different segments, PDU. Protocol data unit. Okay, so data link, we call it as a VLAN. Network IP packet. So transport, we call it as a segments. Applications, we call it as a data lah. Okay, now we're going to see the whole process lah. They show you the example whenever I have a ARP. Okay, I have an IP address, but I don't know where is it the MAC address. So what happened? Okay, you're going to look in on your ARP cache. It will be have the empty, and also on your MAC address also is empty. Okay, so now what happens? They will going to encapsulate the package. The host 1 you will going to look in on your local ARP of cache for your host 1. But here now you are the empty. Then your switch is you just power on. So basically you still in the initial state. You also don't have any entry under your MAC address tables here. So how you going to view the MAC address tables? You will display MAC address reverse. Okay, the next one is what happened. Recall back on the week 1. We're going to say you now have an IP address, but you don't know who actually holding this IP address, what actually is a MAC address there. So you were going to trigger your ARP. So you were going to send out your ARP request, okay, in which your destinations of the MAC address, it should be a broadcast. Okay, broadcast MAC address on here. Okay, but you know the IP address of the IP1 and also the destinations IP2, but you don't know what actually is a MAC address of the IP2. So that's why you were going to send the ARP. Okay, so on here, you still looking on your switch, so nothing's actually you will having to learn it lah. Okay, but under your ARP request, okay, your sender MAC address, your IP address, but your destinations you do not yet. That's why you're going to put 00. You don't know what actually is a MAC address for the IP address 2 here. So once you're going to send the broadcast ARP, okay, now the host 2, they receive on it. Example, if I am the host 1, it's not my IP address, kan? So I just ignore. Okay, but on the host 2, I looking, hey, this one is my IP address. Okay, it's my IP address 1.2 on here. So what happened? I will going to deploy. I will going to send a deploy to the ARP request on it. Okay, but before that, we looking on here. When you're going to send the ARP request, basically your switch will going to start to learn your MAC address, update their MAC address tables. So they were going to know the G001, okay, actually to learn based on your source of your MAC address. Okay, your source of your MAC address, so it should be a 001 on here. Okay, so after that, whenever your host 2 is received already, they were going to send the ARP request, reply, message, deploy. So what happened? They received the package. So switch here, they will start to learn now. Okay, for this G002, actually their source MAC address is a MAC address 2. Okay, so they going to call it, okay, it's a G002. So next time when I going to receive, okay, I want to reach up this IP address or this MAC address, I will going to send out with this G002. But on here, your ARP catch, you will have the destinations MAC address, you will going to update, your sender, you will going to update is a MAC address too. So your destination, because you need to send back to your host 1. Okay, so it's not very difficult. You just need 2 times to digest on it. Actually, the concept is very simple. Just sometimes they put too many slides. Maybe you will be confusing when you going to look in the many slide on here. Okay, so if you cannot going to follow, just going to deflash back my video and play into the slow mode there. Then you will going to understand what actually I mean there. Basically, on this one, we actually have been explore on your week 1, okay, under the ARP. Okay, so now we try to do some of the quiz. Okay, layer 2 Ethernet switch generate a MAC address tables entry based on. You look in based on. So remember, it should be based on a source of the MAC address. So answer it should be A. A switch have a AT interface, and you request enter the switch through one of the AT interface, but the switch cannot going to find the destinations. We cannot find the destination. So in this case, which of the following operations will be performed by a switch? If I cannot find under my MAC address tables, I cannot find the entry not exit. So what happened? I will going to do a flooding. Okay, not discarding. If let's say here they're going to change to the IP package, okay, routing tables, then it's a disgusting. But here you are under the Ethernet, it should be flooding. So I think that's all for our first topic for this week. We're going to learn a very basic MAC address. So remember, we still will have a part 2 to talk about your VLAN. So let us go into tab 5 before we're going to start another important concept under the Internet switch VLAN. Okay, so let's start again on another part two for your, we will more focus on the another important technology under the layer two, data link layer, okay, or we call it as a Ethernet switch layer. So we call the topic, we call it as a VLAN, virtual local area network. Okay, so remember previously we mentioned that the Ethernet technology, they basically they're going to implement the CSMA CD or the carrier sense multiple access with a collisions detections. So whenever you have a very large of the PC, you are connected under your Ethernet. So basically, most of the issue is your performance lah. Basically, you were going to closing a broadcast storm and also the security risk, which will go into causing your very poor network performance there. So that's why in order, because we also cannot going to purchase many switch in order to break our network, okay, because the switch is not that the cost is very expensive. So they come out a new idea. They call it as a VLAN. Okay, VLAN stand for Virtual Local Area Network Technology. Okay, to solve this issue, instead you're going to purchase a physical switch or bridge to break the collisions domain. So what they're going to apply? You can going to apply the virtual local area network, which are not only going to break the collisions domain, but also the broadcast domain on here. So on this topic, we basically we're going to study the fundamental concept of the VLAN, virtual local area network. Okay, so basically you were going to understand the overall VLAN technology, okay, and then you were going to understand how actually we're going to differentiate the package, the plans that we receive for a different VLAN. Okay, so you need to go into understand how what we means by a tech plan, how what we means by untech frames, and also you need to know the difference approach for assign a different VLAN. So basically for HCIA Datacom, we more focus on how actually you're going to assign by using a port base, or we call it as an internet interface base, and also the MAC address lah. But basically you have others approach also. Later you will go through also some of the other approach, but that one is more under your HCIP advanced routing and switching syllabus step. Then after that, we were going to go through, okay, whenever we go into enable the VLAN, we assign a plans to a different VLAN. So how actually the data can be communicates, okay? Then we were going to learn also the configurations, how you're going to apply into the real world. Okay, the first thing we need to understand the VLAN, okay, like just now we said, okay, why we need to come out the VLAN? Because we want to solve the issue of the traditional Ethernet. Like what I said just now, okay, most of the times, if let's say we, example, under our faculties, we have many department. We have the research departments, we have the academic departments, and also we have students from a different program, example, and different class. So normally, how this PC they are connected? Okay, basically you were going to assign the access switch on here, right? Then the switch you were going to aggregate it on the switch 2 on here, okay, to connect them. But when you're going to assign all of this one on here, you are going to allocate them under a one local area network. Okay, so what happened is whenever, okay, the switch one, they going to send out, okay, the frame, unicast frame from your PC one. But if let's say, okay, they cannot find the entry, okay, where is it the destinations of the MAC address there? So what happened? Remember on the previous topic, we're going to learn in a layer 2, if we unknown, okay, the entry is did not exist under your MAC tables, right? You are going to learn based on the source, but the destination is not exit under your MAC address table, not exit on here, tak ada, you search no exit. So what will be happen? You will going to flooding, okay? You will going to broadcast all into a PC, okay, and switch that connected under the same local area network. So imagine that if our faculty, we have 1,000 students. So all the connected PC to our local area network, they will going to receive a broadcast. Okay, the spawning, the flooding of the plan. So it will be some kind like actually you are wasting your network resources because first thing you have consumed a lot of the network bandwidth, and also basically you will going to receive like the email, you receive a lot of the jump traffic issues there. Okay, they will going to broadcast. But in the real world, basically only your PC2 is here. Okay, maybe on here then you not necessary to forwards into the switch 5. You not necessary forwards to the switch 7. You basically need only to forwards to a switch 3. So in order to reduce this issue, okay, they introduce the idea, they call it as a virtual local area network VLAN. So on these VLANs, they were trying to group all the deleted PC based on your application scenario and also the functionality. They were going to group it. For example, they group all the PC under this lab 1. Okay, they are connected under the switch through as a one local area networks. Okay, the others, they also going to group it under another local area network. Maybe they call it as a VLAN 10. Okay, maybe here you call it as a VLAN 5. So you group them into a different group. So the first thing, whenever we want to reach out for the switch tree, okay, we on the switch tree, you only broadcast to the your VLAN server. Okay, you will not going to flood all the plan into the other switch. They are not under your same group or the virtual, we call it as a VLAN. So the advantages always they were asking under your HCIA Datacom multiple choices. What is the benefits or the advantages or the problem they're trying to address by the virtual network? So first thing they were going to limit the broadcast domain because you no need going to flood to all the switch, layer 2 switch and also the devices, layer 2 devices. And also you were going to enhance the local area network security. Why? Because you already limited each of the PC. If let's say I want to communicate with this PC, actually I cannot go into communicate directly because they are belong to a different VLAN. I only able to communicate with these two PC only and my switches lah. Okay, so actually it will go into isolations, okay, and also increase the LAN security, and also it will going to improve the across the network robustness because it will go into bandwidth consumptions, everything it will be largely reduced there, and also the consumptions on your switch. Okay, and also the last one, it will allow the flexible definitions of a virtual group. You can go into partitions, even the PC2 you assign also to another VLAN group. So it's flexible for you to assign on it. Okay, so now you briefly know, okay, why we need the virtual local area network or the VLAN. The next step, we were going to understand how it works. Okay, so basically for the VLANs to work it, they're using a idea, they call it as a tagging. Okay, how I going to differentiate this plan? Okay, remember when we move to layer 2, okay, later link, we no more call our data is a package. We call it as a frame. Okay, when I going to receive the frames, so how I know this frame is belong to VLAN 10? Okay, then only I ensure the PC4 can be received, but PC3 belong to VLAN 20, they cannot communicate with, receives my frame here. So they use the idea of the tagging. That means they will going to add on the frames. Okay, they do the tagging. Okay, this frame do the coloring tagging. Not actually not coloring tagging. So they're going to tag it is belong to a VLAN 10. Okay, so this one VLAN 20. So they are at the tagging belong to a 20. So when your switch going to forward your flanks, okay, between a different VLANs, they know how whether okay this tagging 10 one is belong to me, my VLAN 10. So I allow them to pass. Okay, so this one is the idea they work behind the virtual local area network tag. Okay, so this is what I means here. Okay, how large a switch identifies the VLAN to which a receive fans belong to. So we are using a tagging, and under the tagging, we call that one is a VLAN tag. Okay, so VLAN tag, remember, they have under the standardizations under the IEEE X02.1Q FLAN, or normally we also call it as a VLAN FLAN, okay, or 1Q. Okay, so on here, you will going to ensure if let's say the switch, they're going to receive your friends together with you are taking with a 20. So the switch will know they only need to forward the data to the VLAN 20 only. But VLAN 10, they will not going to forward the data until here. Okay, the next step, we were going to understand what we means by the VLAN FLAN. Okay, VLAN FLAN is actually embedded into your Ethernet FLAN. Okay, so remember under your Ethernet FLANs, okay, basically you have your source destinations, and then you have your LAN data and also the FAC. Okay, that you have learned it on the previous topic on that. But where is it we're going to embed the VLAN text is under, we were going to put it after your source MAC address. So here we were going to insert all the VLAN text on here. Okay, so the first thing you need to know how many, okay, bits of the bytes of the VLAN text there. Okay, so remember on the VLAN text, the first thing you need to know that the protocol, the tag value is at 0x100. So recall back on the previous one, how I know is a IP. So it's a at 100. So 0x06 is stand for ARP tag. Okay, so now you learn one more. It stands for a 100. It stands for a VLAN tag there. Okay, so these VLAN tags, they have a TPID, tag protocol identifier, which we're going to identify the tag of the friends lah. Okay, so this one, you were going to use it. And then you also have a priority, especially you want to manage your traffic flow. Okay, so you were going to set the priority. So priority, if we are going to consume is a 3 bits. That means 3 bits, the maximum one is a 111. So the value you can going to accumulate to assign maximum is a 7 lah. So starting from a 0 to 7. Okay, and also you have a 1 CFI. Okay, we call it as a canonical format indicator. So this one we're going to decide whether your MAC address is a canonical format or not lah. So normally for the Ethernet FLAN, you just going to have a 0. Okay. Then also another one, you have your VLAN ID. So this one we're going to identify the VLAN to which FLANs we're going to belong to lah. Okay, but where you're going to insert your VLAN tags under your Ethernet FLAN. Okay, so basically your tag will be entered here. Okay. So this one is another explanations lah, because sometimes most of the times the HCIA data comes, they will come out the questions from the documentations on that part. Okay, so this one is where you're going to looking more clearly. So remember, in the VLAN, okay, your FLANs, you either can have a tag and also the untag. Later, we were going to see in what scenario we were using is a tag, in what scenario we were using is a untag. But you just remember, most of the times, whenever you are the user, host, okay, or the simplified layer 2 switches, normally you are only process is a untag frame. Okay, that means you are the end of the host. Okay, so you are untag. But switch, router, AC, basically you can going to process both tag and untag. And also this one is under the voice terminal and also the access point there. So also you were going to process is a tag and untag frames lah. Okay, so for the VLAN ID, okay, VLAN ID, you know that it will going to consume 12-bit VLAN ID, okay, VID. So you take the 2 power of 12, you will get is a 4096. So remember the range of the VLAN ID is a 0 until 4095. But the values that you can going to use it to assign your VLAN identity, you only can use one up to 4094 only, because 0 and 4095 is the reserved one. You cannot use the 0 to assign as a VLAN ID. You cannot use the 4095 to assign as a VLAN ID there. Okay, so remember, because this one always they will asking under the SCIA datacom questions. Okay, which of the range of the VLAN ID that you can use? 1 until 4094. You cannot going to use the 0 and 4095. But the default VLANs is a VLAN 1. Lah. Okay, now you already understand how the VLAN flan or VLAN tag it will be inserted under your VLAN, and you also understand how the VLAN flan format it will be look like. Basically, you have these four contents there. Okay, for your VLAN tag. The next one we were going to understand whenever on the switch, okay, on your on host, how actually we going to process your VLAN implementations there. Okay. To understand the VLAN implementation is just like what I said. Most of the times when your PC you send to a switch, okay, your PC most of the times you send to the end device. Just now I mentioned when you're going to sense when you're going to sense to the end device, your user, your host server, hub, simplified layer 2 switch, most of the time is a untapped frame. So that means when you going your PC, you send out your frame is a untapped. But when you're going to reach up the switch one, they were going to add a tagging. Okay, example for this one, they were going to add your data. Okay, and then they would, example here is your data, and then they were going to add is a VLAN 10. And then going to forward. And the switch 2, they were going to base on your tagging to differentiate the traffic, the frame, so that you were going to yellow one, VLAN 10s, they were going to forward to the PC4. Okay, the same thing for your PC2. You add the 10, here is your VLAN 20. So you forward to the VLAN 20. Okay, next one we were going to understand how actually we going to assign the VLAN. So this one they also has been asking under the SCIA data questions. So remember we can using a port base, or we call it also is a interface base. So you just going to assign based on your interface. Okay, you go through the interface, so you assign the VLAN ID. Okay, into your port or the interface. The second one is you can go into assign based on your MAC address. Okay, that means you do the mapping, okay, between your VLAN and your source MAC address. Okay, it's referred to a source, not the destination. Okay, where is it? Okay, source MAC address. Okay, another one, this one is under the advanced. Okay, so you will not going to explore under our SCIA datacom, but you should know you also can go into assign the VLAN based on the IP subnet, and also you can go into assign based on the protocol and also the policy base. So how many methods you can go into assign your VLAN? 5 methods: internet base, MAC address base, IP subnet protocol base, and also the policy. Protocol is based on the what kind of the protocol that you're going to apply. Okay, and then policy is most of the times you have specified. Okay, you have configured some of the policy, so you will go into handle that one based on the policy. Okay, so we're going to see the first, of course, you were going to asking kan. So in what conditions I will going to apply and assign my VLAN, either based on port ke, interface ke, or MAC address ke, or how actually I going to assign. So for here, you were going to looking on the next slide. Okay, it will explain the scenario how where you going to apply the different type of the VLAN assignment. Okay, interface base is most of the times we were going to apply under the industry. The condition is most of the times your devices will be located under the fixed location. Okay, widely using in the industry. and most of the times your devices is a fixed location. Okay, so this one is more flexible for you lah whenever you're going to do the configurations on here. So basically, you will going to base on your interface. That means your port. Okay, to assign them to the VLAN. Okay, so remember every port. Okay, every port they have a PVID. Okay, we call it as a port default ID. Okay, port default VLAN ID. Port default VLAN ID. Okay, so remember the default ID is a 1 lah. Okay, another one is the here. Okay, you have to remember VLAN assignments for this interface space is quite simple and easier to implement lah. Okay, most of the times we just going to apply it under your industry with the assumptions that all the devices always they will located under the fixed locations. But sometimes, example, we have a how to say the remove. Okay, not fixed. Our office is not fixed. Always keep changing. So at that one, you need to assign your VLAN based on the MAC address. Okay, based on the MAC address. Okay, so that they can be memory-free, move from one building to another building. So most of the times, it will going only apply to a small scale of the network. Okay, in which your user terminal, that means your PC, your host, will often changing. Okay, but your network card, MAC address, you seldom going to change it. Okay, for example, your laptop skirt, okay, your mobile's computer. Okay, so on that part, we will going to do a assignment based on the MAC address. That means we will do a mapping between your MAC address with the VLAN ID. Okay, so this one is a bit complexity compared to how we going to assign using a interface base lah. Okay, but okay, this one is only the two scenario they cover under the HCIA, because on if you want to apply under the IP subnet protocol base and policy, you need to study a more on the IP protocol and also the policy, especially when you're going to handle for the security one lah. Okay, now we go back again to here. After you understand already what actually is the assignments, how many types of the VLAN assignments that you can go into apply, we will start to learn the interface types. Okay, we have under the VLAN, we have three types of the interface. Okay, we call it as a access interface, trunk interface, and also the hybrid interface. Okay, for a access interface, most of the times they are the users, host, user host, or the terminal, or the server. Okay, like this. So their interface that you are connected, most of the time they process only is a untapped frame. Okay, remember just now we mentioned on the beginning kan? So now you can link all together already. User, host, server, hub, simplify, most of the times they are sending is a untapped frame. So now you add one more thing is they will going to send out via the access interface. Okay, so that means whenever you have a switch, that switch the interface, okay, which you connected to the end user terminals, user host. Okay, so you were going to assign them as a access interface. So if let's say trunk interface, most of the times they can go into process tagged and untagged frames. Okay, most of the times is you going to connect to another switch or sub interface on the device lah, or example router ke firewall. So that one you were going to assign as a trunk. Okay, trunk interface. Okay, the hybrids one actually Cisco, I think they don't have, only available used under the Huawei devices. So the hybrid actually they allows the multiple VLANs to pass through lah on the differentiated plan. Later we will going to look in detail how the hybrids they difference from the trunk interface. Because of the trunk interface, you will go into process the frames belong to a multiple VLAN. Okay, but the hybrid at the same time, they also can behave like a access interface also. So we will going to look in each of the interface in a very details before you're going to move to understand how you do the configurations there. Okay, for the access interface, whenever it's a access interface, so you just remember most of the times they're dealing is a untagged frame. They were going to send out is a untagged frame. So you need to differentiate whenever the frame is receiving. You receive the frame. That means here I am the switch. Okay, whenever the PC, I send the frame. So it means here your switch is going to receiving the frame from your PC. So remember, always on here, you are going to set it as a access interface, right? So basically, you receive is a untagged frame. So when you receive the untagged frame, so what will be happen? You, if let's say the interface is permits the frames, you are going to add the VLAN tag based on your PVID. That means your port default VLAN ID. So on here, that means your port default VLAN ID, you configure as a VLAN 10. So once they receive the untagged one from your PC, you're going to send it. So what happened on your switch? They were going to add a text VLAN 10, the same tag on here. They were going to add on it. Okay, the next step is the same thing. If the VLAN tags, okay, sometimes your switch, okay, you were going to access the tag frame. It's a tag frame. Okay, you receiving from other side. Okay, so you're receiving from your other ends interface to your inside your computers, right? You have a tag frame. So what happened? You check whether they are the same PVID. You allow them to pass or not. Okay, if yes, you just going to allow it to pass. If not, then you were going to discuss one there. So you were going to check out whether it's allowed or not. So what happened is whenever you want to send, that means you want to send on here, okay, to the PC. So whenever I receive from somebody else, maybe on here, I'm going to send to the switch and then I reach out on here, right? So I receive on here. So now I want to send to a PC. It's a access interface. So what will be happen if the tag is the same with my VLAN ID? So I will going to remove the text and I send is a untag. Because on the access interface, you only can send is a untag. Okay, so the same thing under the inside. Okay, if difference, you just going to discuss. So just remember under the access interface, as long as okay they are different, so you were going to discuss, and they only permit the frames in which your VLAN ID is same with your PVID. Okay, the tag of the VLAN ID, if you are the same, you allow them to pass. If they are not same, 20, but here is your PVID is a 10, so you were going to discuss it. Okay, this one is the access interface. So to make it simplified, you just remember access interface, you only going to send. Okay, it's a untagged frame and receive a untagged frame. Okay, so if you receive the untagged frame, you check the PVID. Okay, so you were going to add your VLAN tab based on your PVID. But if you receive is or sending is a untagged frame, so you check whether it sends with your PVID or not. Okay, if not set, you're going to discuss. It's sent, you're going to allow them to pass lah. Okay. So for the Trump frame, you just remember they only allow the frames your VLAN ID is on the list of the permitted. So you were going to configure Trump port allow pass VLAN, which of the VLAN ID that you permitted them to pass it. Okay, so remember the trunk, we're not going to check whether like interface is same with our PVID or not. Okay, but we check whether they are under the permitted list or not. Okay, if permitted, that means we're going to allow them to pass lah. Okay, so it will allow the tag friends from the multiple VLAN, but the untagged friend, this one is make the difference, but the untagged friend is only from one VLAN to pass it. Okay, we're looking on here. So if I going to receive a untagged friend, okay, so what will be happen? I will going to check whether they are allowed to pass or not. Okay, if they are not allowed to pass, so I will going to remove it. That's all. Okay, if I going to receive, so I also going to check whether they are permitted or not. VLAN 10 permitted, right? So I will allow them to pass. Okay, the same things on here. Untagged friend, when I going to receive, I will check whether they are permitted or not. If yes, okay, but I will going to check on here, okay, is under the list or not. But you remember for the untagged friend, you were going to add your PVID, belong to your PVID. Your PVID is 10. So now 10 you allowed to pass? Yes. So you were going to add the tag on here. Then from sending the friends the same things, okay, if the VLAN ID is permitted and it same with your PVID, so what happens? You are going to remove it, the untagged friend. Okay, if they are not, even your PVID is 10, but the 20 is under your permitted list, so you will go into forward it. Okay, you only remove the text whenever it same with your PVID. Is same, you were going to remove. If not same with your PVID, you were going just to forward because you allowed them to pass. So you forward it directly. Okay. So now we go to apply the whole scenario. Example on here, you have two switch. Okay. PC1 you assign to be a VLAN 10. PC3 you assign to a VLAN 10. And then PC3 you assign to a VLAN 10. PC2 you assign to a VLAN 20 and PC4 to a VLAN 20. So of course you already know whenever each of the interface they are connected to my end devices and terminals, I will going to assign is a access interface. Okay, then the two switches I will going to assign them as a trunk interface. Okay, this one is trunk interface. This one is access interface. Okay, so now we see the scenario. Okay, example, if let's say PC1, we send the flame. Of course, it's an untagged, right? Because it's an end device, it's an untagged. So what happens when the switch one on this port I going to receive? I will going to add on the PVID 10s. Okay, I will going to add on the 10s under this frame. The same thing when the PC2 send is an untagged frame. But on here, I will going to add on the 20. Okay, to the this one. I add on the 20 on here. So when this trunk interface, okay, I want to sending my friend. Now I already set up, I already add already. Now this one interface, trunk interface, I will going to forward sending. So I will going to check whether this tag VLAN 10 and 20 are allowed to pass or not. So check my list. They already said the trunk interface on switch 1 and switch 2, I allowed 10 and 20 to pass. By default, is a VLAN 1 also allowed to pass, right? You no need to configure. Because all the ports are, they will go into, by default, add it to the VLAN 1. So that means here is allowed, kan? So you were going to forward them. Okay, until the switch 2, now I am the trunk interface. I receive the friends with a tag. So what happened with the tag? I will going to check whether they allowed to pass or not. So check on here, 10 and 20 are allowed to pass, right? So I will going to forward to the corresponding interface on here. So now I am the access interface already. So whenever I am the access interface, I will going to check whether the PVID is the same with my one or not. Okay, so now I will going to receive with the tag 10 and 20. So 10 is with my PVID is the same. So I will remove it and I will going to forward to a PC3. But at the same time, 20 I will also going to receive. But because the 20 is not same with my PVID, so what happened? I will going to discuss on here. So that means the flames of that carry the tag 20, it actually will not going to reaching under the PC3. The same thing under the PC4, under this access interface, PVID 20. So I will going to save when I going to receive on here. So what happened? Your tags, it will going to have a 10, right? So, but my PVID is a 20. So access interface, they were going to discuss this one. No forwards to the PC4. But they were going to check this 20 is same with my PVID. So they untap it and then they're going to forward to the PC4. This is the whole idea how they are going to work lah. Okay, in a real world scenario. But remember, under the Huawei, they have a one spatial interface. They call it as a hybrid. Okay, that means they merge both the benefits of the access and also the trunk interface there. Okay, under this hybrids, okay, you allow the frames they are in the permitted list, but you also going to allow the tag frames, okay, from a multiple VLAN to pass through, and frame will going to send out the hybrid interface. They can be tagged or untagged. Okay, it's not like your trunk. Okay, so in a hybrid, you were going to send is a tag and also the untagged frame. Okay, so remember how they going to difference from the trunk interface. Trunk in the hybrid interface, you allow the untagged frame to pass by. But under the trunk, you did not going to allow the untagged frames from a multiple VLAN to pass through. Okay, so we're looking on here. So what happened if I going to receive the untagged frame? So basically, I will go into check whether they are under the list of the permitted or not. If yes, I just going to allow them to pass. It's just like a trunk. Okay, so when you're going to receive, also the same. They were going to check whether it's the allowed to pass or not allowed to pass. Okay, so inside here, whenever they're going to access, okay, the same things, they were going to check whether allowed to pass or not. So they going to untag whenever it's sent with the PVID, and they remain it whenever it's permitted, but the PVID is not the same, so they were going to receive on it. Okay, the differences, if you're going to look in on carefully, so is they will go into, remember, on here, your trunk port, you only allow a untagged friend. Only from yourself. Untagged friends from yourself. Okay, sendiri saja. From only one VLAN. But the hybrid, you allow from a multiple VLAN. Untagged friend from multiple VLAN. Trunk, you only allow the untagged friend from one VLAN saja. Sendiri PVID, send with your PVID. But for the hybrid, you allow it to pass is a multiple friends to pass it. Okay, so we're looking on the example on here. So if you're using a hybrid, most of the times you are going to configure because they can be behave like a SS and also they can be behave like a hybrid. So you were just going to assign all as a hybrid interface on here. So when the PC1, they're going to send it, okay, it's an untagged friend. So what happened? They were going to add the tag on here. Then they will behave as a access. Okay, add on your VLAN 10. Okay, then the same things for your interface on here. They were going to add on to a 20. And then on here, they were going to behave like a trunk. Okay, so they check whether they allow pass or not. Okay, 10 and 20. You check on the interface tree. Switch 1 interface 3, you allow 10 and 20 to pass, right? So they will going to forward. So until your switch 2, okay, your switch 2 here, you check, you make it as a PVID 1. Okay, so but you allow interface 3, you allow 20 and 10 to pass through also. Okay, but you reach out the interface 1, even your interface 1, your PVID is a 100, but you still allow them to, you were going to do the untag. Okay, untag, remove the 10 and 20, you allow them to pass. This is the differences lah, how they going to work differently from the trunk interface there. Okay, you have a tag and also you have a untag, the permitted list. Compared to a trunk, okay, you only have a permitted one. Okay, but on the hybrids, you have a tag and untag. You are permitted list. Okay, so now you are going to see the overall summarizations on all the scenario, how the access trunk and also the hybrid. And remember, the HCIA Datacom, they very like to asking the questions. A lot will be coming from this few slides. So you have to make sure you comprehend on all the what we mean by access interface. So when the access interface, we're going to receive the untapped frames. So it's sent with my PBID. It's not sent what I'm going to do. So all you need to understand the process on it. Okay. So on the, of course, in a real world, okay, we don't go into how to say to do it one by one. Okay, we will going to enable what we call as a NAP, even though it's not under your syllabus, but it have been cut out under the HCIA data questions NLP. Okay, remember NLP is stand for the Link Type Negotiations Protocol. So basically, they were going to dynamically negotiate the link type of the Ethernet interface. So they were going to negotiate either it can be a access or the trunk. Okay, so this one is very useful whenever you have a topology change on your network. So you no need to reconfigure against, and also the configurations will be complex, right? Because you need to assume every cases of the link or the interface they were going to down. Okay, so that's why they introduce a one protocol, we call it as an NAP, to handle the outdoor negotiations of the link types under your Ethernet interface. Okay. Okay, so the next one we will start to know. Now you already understand what is a VLAN, how they going to working. Okay, how you going to do the assignment based on the port, port base or the interface base and MAC address base. But remember, you still have a protocol policy based in IP subnet mask. You have 5 types of the VLAN assignment there. Then next one, we were going to see how you're going to apply into the real world environment. So basically, in the real world environments, how you going to assign the VLAN? You can go into based on the services. Okay, that's your organizations or the enterprises offer. Example, video. Okay, you have a video conferencing or you have a lot of the voice call. Okay, you can go into partitions based on the services and or your end devices, and also the data VLANs lah. Okay, the departments one. And also you can go into assign based on the different departments functionality. Engineering, research, financials, human resources, all that. And also you can base on the applications. You not necessarily assign the VLANs based on one. You can go into mix the components there. Okay, but remember always the tips. Okay, you are allowed, we know you can go into assign is using the VLAN ID is 1 until 4094. Okay, but the VLAN ID is from the 0 until 4095. But this two is a reserve. You cannot going to touch it. You only can assign 1 until 4094. But we still good practice if you have to associate based on the continuous lah. Most of the times we base on the subnet, your IP subnet assignment there. So here they give you the example. Okay, you go to one enterprise, you want to set up the network. Okay, they have a 3 building on that. So you have an administrative, you have a classroom, and also you have a financial. Example, you go to a college. Okay, you want to set up the layer 2 for them. Okay, and also the teaching building with all of this one, and then you also have a office building. Okay, so how you exactly going to do? They tell you each of the building, you basically will going to assign a one access switch there. And also the core switch, you were going to assign under your administrative building. Okay, that means your office building lah. So how you going to assign? Okay, based on your IP subnet. Okay, you're going to using is a /24. Okay, 10, 20, 30. You're going to assign. So you just assign your VLAN based on your subnet, 20 and 30. Okay, so it will going to ensure the VLAN's continuity lah. When you're going to assign, you will know kan, sekarang when I want to open a new IP subnet, so it's 0.40. So I know I can using a VLAN is a 4. So this is how they're going to assign lah. Example, okay, one, they were going to assign to the office use. okay, financials department building, classroom user. Okay, even they are located under a different building on that one. Okay, so another types, if let's say, okay, your sometimes under the enterprise, especially now they have a new concept how actually to share resources, right? So you might have a multiple enterprises under the same building and they actually are sharing the network resources in order to reduce the cost. So at that part, you actually are connected to a different interface under the same switch. So example here, you have an enterprise one. So what happened? You were going to allocate all the enterprises user along to one VLAN. Enterprises, so you assign to another VLAN. And three, you also assign to another VLAN. So this is another example where you're going to apply the interface-based VLAN. Okay, if you have a different enterprises, but they are sharing the resources of your network. Okay, if let's say you are using is a MAC address, basically is remove. Okay, you take your PC, you keep removing. So that one you will going to using is a MAC address. So you just need to get the PC MAC address, then you going to uh, assign the VLAN to good then. But remember, whenever you have another PC, so this PC actually they cannot going to access your VLAN 10 and communicate with the PC 3. Okay, except you assign do the configurations to allow them to communicate lah. Okay, so now you understand in a real world how actually you're going to apply your VLAN applications. We are going to learn how you do the configurations there. To create the VLAN also is quite straightforward. Okay, you're just going to define the VLAN. Okay, VLAN 10, VLAN 1. No, 1 now, 1 is by default. Okay, and then VLAN 3. Okay, so remember by default, all the VLAN you will going to add to the VLAN 1. Okay, so you no need to specify the interface, then you add to a VLAN 1. Because by default, they already add into the VLAN 1. Okay, so what happened if I wrongly typo kan? Normally for the numbering, some students, you supposedly you want to create is a 10, but you wrongly, you're going to type 1, 1. So remember, you always can undo VLAN. Okay, so that one they will going to delete the created VLAN. Okay, and then of course in a real world we don't create one by one. If let's say you have a 10 VLAN, 10, 20, 30, 40, 15, you no need to create one by one. You just need to specify, okay, VLAN batch from 10s, okay, to 15s. Then they will going to help you to generate on it lah. Okay. Okay, so now if let's say you want to assign the interface type, just now you learned the three types of the interface, assign interface, trunk interface, and also the hybrid, right? So how you going to assign? You will going to using a port link type. So you tell them you want to assign is a access. Okay, this one is a access interface. So most of the times on the access interface, you are going to set your PBID. Okay, your port default VLANs. So which of the PBID that you want to assign. Okay, for the trunk, the same things, you need to assign this interface G00 as a trunk, not access. Just now access, you put access. It's a trunk. So remember, trunk, we have a permitted list of the permitted list of the VLANs that you allowed to pass. So you were going to using this one, allowed pass. But of course, you have to tell them it's a port trunk. Allowed pass, which of the VLAN? Okay, or all VLANs. Seldom we using all VLANs lah. Okay, but which of the VLANs you allowed to pass, but you can doing the batching also lah. No need one by one. Then also you can go into configure the default VLAN. So you are going to tell them what actually is your PVID VLAN and your VLAN ID. Okay, for the hybrid, the same things, you need to tell them their DIN type is a hybrid. Okay, so you need to tell them what actually is a VLAN you want to untag and then which of the VLAN you want to tap on it. Okay, and then you're going to set, okay, chance exactly same port trunk. Just now is a port trunk, you set the PBID. So here you are going to port hybrids PBID VLAN. Okay, so this one later on, under the lab sections, you can going to go through, okay, how actually you're going to do the interface VLAN. So now they give you the scenario lah. You have a switch 1, switch 2, you connected to a multiple VLAN. So now you want to assign a 2 VLAN. Okay, that means you want to allow the PC1 communicate with PC3, but cannot communicate with PC2 and PC4. So you make the PC1 and PC3 belong to a VLAN 10. Okay, and PC 2 and 4, you belong to a 20. Okay, so here they show you an example. Okay, how you going to assign? You can going to create one by one, or you just going to using a VLAN batch. So remember, each of the switches, you have to going to create the VLAN. So that's why on here, you were going to create again on your switch 2. Then after that, you are going to enter your switch 1 to assign G001, G0302 as a access trunk point. And then you're going to assign their PBID. Okay, PBID. Okay, then you're going to access again to your switch 1. Okay, then you're going to make them as a trunk port. Okay, default PBID and also allowed pass is a 10 and 20. Then you will do the similarity on a switch 2. Must do on the switch 2, then you're going to display lah. You should able to get the 1 is a untapped. Okay, PBID 1 is a untapped frame, 10 and 20. Okay, is a tapped frame. Common. So untapped frame is under here. Okay, tapped frame it will be under G003. Belong to a PBID 10. Okay, so you can try also by using a second scenario by using is a hybrids. Okay, then you can go into trying to verify your configurations lah. Normally we just going to display VLAN, or you trying to do the Wireshark package capture. So later on under your lab sections, I will demo to you how you're going to do all the things lah. But on here, we just going to explore and get familiar with all the commands. Okay, so of course, you can go into assign based on the MAC address. You need to get the MAC address of your PC or your devices, okay, to do it. And then you have to enable your VLAN, MAC address VLANs to enable on it. Okay, so this is how the examples that you're going to do the configurations on here lah. Okay, you assign, create the VLAN. So you're going to enter the VLAN. You tell this VLAN which of the MAC address, okay, 001 that you want to add into the VLAN 10. Okay, and then you add again the PC2, you add again your PC3. Then you're going to quit it. Okay. So this one is the same example lah. But make sure after you add the PC, you have to enter interface for your hybrids types. Okay, to enable your MAC address assignment there. Okay, so let's try the quizzes before we end up for this topic. Okay, which of the following statement about the VLAN technology are incorrect? Okay, we're going to check. The VLAN technology can isolate a large correlations domains into the serverless correlations domain. Okay, remember the VLAN we are focused is a broadcast. Okay, broadcast domain is not the correlations domain. So the first one is incorrect. The VLAN technology can isolate, this one is correct. So PC in different VLANs cannot communicate. PC in different VLAN cannot communicate. You have to go to another next topic. We were going to discuss how you enable a different VLAN going to communicate. Okay, PC. So this one is wrong. You can communicate. You just need to do the inter VLAN only. Another PC in the same VLAN can communicate at layer 2. Correct. So answer A and C is incorrect. If the PVID of a trunk interface is fine and the port trunk allowed pass VLAN 2 and 3 command is run on the interface, which of the flags can be transmitted through the interface? Okay, so remember, if 2, 3, your PVID is fine. but you only allowed 2, 3. So what will be happen? So remember, even is a trunk port, so your VLAN file, it cannot go into transmitted. Okay, by default, but one can be lah, because all by default the trunk can be. So who can go into transmitted under this? You allow through 3, but remember by default you have 1, so you should be able to allow 1 to 3. Remember, even though you set it, your PVID is fine, but you not add it into the allowed pass. So actually the VLAN file, they cannot go into pass through. Okay, you only based on the allowed VLAN pass. One, you don't need to specify because by default, VLAN 1 is a default VLAN, so it should be able to pass through lah. Okay. So which of the following VLAN ID can be configured? So just now we mentioned 0 and 4095 is a reserve. You cannot go into configure, right? So maximum you only up to 4095 only. So this one cannot, this one are not out of the scope, right? So you only can configure is a 10. If the PVID of the trunk interface is fine, this one just now we already mentioned. So now they just devise the questions. It's a 10 and 20. So that means you only allow 1, 10 and 20 can go into pass through. So answer it will be a donkey. So which of the following statements about the VLAN is false? False. The default PVID is 0. No, default is a VLAN 1, so it should be a 1. Access port are used to connect a terminal and trunk port are used to connect to switch. Access port are used to connect to internet, to terminals. True, right? And the trunk port are used to connect the switch. True lah. Okay. Then the other answer C, the default interface Huawei S series switches is a hybrid. Yeah, this one is a default one under the Huawei S series switch or the default interface. If you did not go into transit, they were under is a hybrid. This one is true. So access port can process the data frame. No. So remember, access port, you cannot go into process the data frame from the multiple, only for yourself only, the same PVID. So answer it will be A and D is incorrect. Okay, so a VLAN is a broadcast domain. Yes, true. Okay, to restrict the access of the specified host to a specific resources, you can configure the VLANs based on the MAC address. True? Okay. Then, which of the following statement about the VLAN technology are incorrect? Are incorrect. You need to find the are incorrect. Double two. So the VLAN technology can be isolate. This one actually we have went to just now, right? Correlations, no. Blockouts, yes. Okay, so in a difference cannot. No, we can in the VLAN. So this one is true. So answer only A and C. So I think that's all for this topic. But remember, we still have another subtopic. How actually we want to ensure the communication if you under a different VLAN. How actually we going to enable them to communicate. Okay, you have to go up to the layer 3 and we will learn that one under the inter VLAN topics. Now we will going to jump to the inter-VLANs communications. So did the brief also they got some questions even though some of the questions we have been included under the VLAN 10 topic. Okay, basically on the VLANs, inter-VLANs is allow you to whenever you have a different VLANs. Okay, the host belong to a different VLANs and you want to allow them to communicate with each other. So that means you have to go through a layer 3 routing.
So basically, in one of the idea is you can using a router physical interface lah. That means you assign a one interface G001, assign the IP address, and then this one you will going to access the VLAN 10. But you have to ensure the switch that you connected to a router, it should make it as a access port. That must be the access port whenever you're using a router physical interface. And the same things when you go into doing on here, you assign another interface. Okay, so here also you have to make it as a must be the access interface. Okay, so but this one is in theoretical it can be workable, but in a real world it's not practical because you need to assign many physicals G01, Z02, okay, and also the others for each of the VLANs that you want to support them. So basically in real world, it will be very costly if you want to allow by using a router physical interface. So what will be happens with using a sub interface there lah, virtualized sub interface. So we going to assign a .10 to talk with a virtual. So again, it will be assigned on here. It will be using a trunk port there, and also .20 we will going to talk with a 20 on that lah. So remember, it will be a trunk interface. Okay, if physical you using is a interface, physical access interface, but if for the sub interface you have to using is a trunk. Okay, recall back also how you going to enable the sub interface. You have to ensure that you going to terminate your VLAN tag here and forward to be the another. Okay, and also you have to enable the ARP enable. Okay, to broadcast your VLAN tag terminations on the sub interface lah. So by default, ARP broadcast is not enabled on the VLAN tag. Okay, termination sub interface lah. So that's why you have to enable it by manually. Okay, so on here you can using a layer 3 switch and also the VLAN if lah. Okay, so layer 2 you only provide a layer 2 switching. By layer 3 basically they can cope with a layer 3 forwarding by using a VLAN if interface. So on here you are going to assign. So basically your VLAN if will be same ID of your corresponding VLAN 10. So example, this one is a VLAN 10, so you are going to create another one is a VLAN 10. VLAN if 10, okay, under your layer 3, and also here is belong to a 20, so you were going to assign a VLAN if 20. So the same things that you're going to assign on here, example, under your G001, you were going to make them as a access port, and also on the G002, you were going to make it as a access port. So under your switch 1, you are going to make your VLAN if 10, okay, you assign the IP address and VLAN if 1020 for this one. Okay, so this one VLAN 1. Okay, you're going to assign on them and also assign the IP address. Okay, after that, how they going to communicate? Because your destinations of the MAC address on here, you are not going to make the destinations of the MAC address of 3 lah, whenever you're going to send for your PC1, but you are going to make the destinations of your VLAN if. Okay, so that means it's a MAC address of 2. So same from here, you are going to make it as a MAC address of 2 lah. Okay, sent by the PC2 on here. So after they going to translate, okay, under the step 3, that means they were going to find the matching routes, okay, the rally route generated by the VLAN if 20 for the package lah. Okay, and then they were going to revise again their destinations of the MAC address. It will be destinations of the MAC address 3 here. Okay, so this one is basically the topology on here. You have a VLAN 10, 20, and also here topology example describe communications with a PC1 in a VLAN 10 to the server. Okay, so you are going to make it 3, okay, 10 and 20 allow you to communicate, and 30. So what will be happen when you want to allocate, okay, the VLANs 1 and 20, and 30 is for you to connect it to a net can. So remember to connect it to a internet one. So remember, when you connect it to the outside, you have to apply the network translations, and this one they using a ports. That means you translate also on the ports, okay, to communicate to the outside. Okay, so this one you're going to refer lah. So remember, you require the ARP or the MAC address entry already exist on all the devices. Okay, we go through to a quiz. When a sub interface is used to implement the inter-VLAN communication, how large the switch interface connected to the router need to be configured? So we can configure as a trunk, or we can configure as a hybrid to permit the package carry the VLAN corresponding to the terminal. So how are the packet chains when being forwarded on the layer 3? Okay, so the source and destination IP will remain unchanged when the package you are going to forwarding, okay, without a net. But the source and destinations of the MAC address you are going to change. Okay, each time a package pass a layer 3, its source and MAC address will going to change it. Okay, how does the package IP will remain the same because it's under the layer 3, but your MAC address, it will going to change it to be your MAC address of your sub interface there. Okay, so this one is a comparison of the layer 2 and layer 3. So you remember, you just go through to